Math 3, Unit 9, Module 4, Part 2, Lesson 3, Converting Between Radians and Degrees. So a little bit of background information to start. The unit that describes the measure of an angle theta in terms of the arc length and radius of a unit circle with a radius of 1, is called a radian. The ratio of the intercepted arc length of a central angle to the length of the radius is the measure of the central angle in radians. There are 2 pi r over r, or 2 pi radians in 360 degrees, because this r cancels out with this r, so it simplifies down to 2 pi. And there are also pi times r divided by r, or pi radians in 180 degrees, because this r cancels out with this r. Degrees and radians are just different units of measurement used to measure angles. It is similar to how we can measure length with inches or centimeters, or miles and kilometers. They're just different units of measurement. So with unit conversions, in order to convert between radians and degrees, we need to multiply whatever we're trying to convert by 1, or specifically by a fraction that's going to be equal to 1. Since there are pi radians in 180 degrees, we either multiply by 180 degrees over pi radians or pi radians over 180 degrees, because both of those fractions are equivalent to 1. So the two formulas to make the conversions, if you're going from radians to degrees, you would multiply however many radians you have. So right here, you'd multiply x radians by 180 degrees over pi radians. And that little 1 is in the background there to let you know that that fraction is equal to 1. If you're going from degrees to radians, you do x degrees times pi radians over 180 degrees. That fraction is also equal to 1. So the tricky thing, obviously, is remembering which version of the fraction you need to multiply by. Those two fractions are they're reciprocals of each other. So the key to remembering, whatever unit you're starting in, you want to multiply by the fraction that has that unit in the denominator, in the bottom. So for example, if you're going radians to degrees, you start in radians, and then you want to multiply by the fraction that has radians in the bottom. That way, the radians up top cancel out with the radians in the bottom, and then you're left with degrees in the numerator, which is good because you're trying to convert into degrees. If you look at that second one, when you're going degrees to radians, if you want to get rid of your degrees, the degrees are what you're starting with. You want to multiply by the fraction that has the degrees in the denominator. That way the degrees that you start with cancel out with the degrees in the denominator, and then you're left with the radians up top in the numerator, which is good because that's what you're trying to convert into. Let's go ahead and do two examples so you can see what I'm talking about. So on number 1, convert 2 pi over 3 radians into degrees. So always just start with whatever they tell you to start with. So 2 pi over 3 radians. So we want to go from radians into degrees. So I'm going to multiply by either 180 over pi or pi over 180. I always want my units that I start with to cancel out so that I can convert into the new units. So I want to have the pi in the denominator because pi is measured in radians, and I want my radians to cancel out. Then the 180 degrees must be in the top. So what happens here, let me switch colors. This radian and this radian, those units, they cancel out. And then you have a couple options here. If you want to just multiply straight across the top and then straight across the bottom and reduce at the end, that would be fine. Or if you want to cross cancel at the beginning, that would be fine as well. I'll show you both ways. So in this method, let me just cross cancel at the beginning. So this pi up top cancels out with this pi in the bottom. Now I'm looking at the 180 and the 3. So 180 divided by 3 is 60. So then the only thing left in the bottom, everything got canceled out. It's just a 1, an invisible 1 down in the bottom. And then in the top, the only thing left is a 2. So 2 times 60 over 1 is just 120. And we're going into degrees, so let's put a degree symbol on our answer. Now the other way of doing this problem, if you didn't want to cross cancel, so start the same way, 2 pi over 3 radians times 180 over pi. And then if I just multiply it across the top, 2 times 180 is 360, and then the pi would be up top. And then in the denominator, 3 times pi is 3 pi. And then at the end, I would reduce. And I guess in this second version, I would still recommend that we cancel out the units. So the radians and the radians cancel out. So then the only thing left, the pi and the pi cancel out. 360 divided by 3 is 120. So you could do it either way. And once we get good at these, I wouldn't even require you having to write the radians and the radians out. Since this is our first example, though, I want to really hit home the idea that the units are canceling out because the radians were up top and then they were in the bottom. For number 2, we want to convert 275 degrees into radians. So start with what they start you with, so 275 degrees times, I need to multiply by a fraction. It's either 180 over pi or pi over 180 every time, because those fractions are both equal to 1. The key here is that I want to multiply by the fraction that has the same unit of measurement that I start with in the bottom, in the denominator. So I want the 180 degrees to be in the denominator. That way the degrees up top cancel out with the degrees in the bottom. The other way to think about it, whatever unit you want your answer to be in, that's the unit that should be in the top of your fraction. So on number 2, since I want my answer to be in radians, I want the top of the fraction to be in radians because that's what I want my answer to end in. On this particular problem, it's not super easy to cross cancel, so I would recommend let's just multiply across the top. So 275 times pi over 180. And then the degrees would have canceled out, so we're not in degrees anymore, we're in radians. And then as far as reducing, the calculator does it for you. So if you have that Calculate 84 app that I had you download before the shelter in place, you just basically type in 275 divided by 180 and then math, frac, enter, and it reduces the fraction for you. So I'm going to do 275 divided by 180, and then I just reduce it. So this particular one reduces down to 55 and then over 36, and then that pi is still up top there. And then since we converted into radians, let's go ahead and put radians on our answer to remind ourselves that that's the unit of measurement that our answer is in. At this point, why don't you try the first, 3, 4, 5, and 6, try those out, or maybe just try one of them and then check the video and see if you did it correctly. And then we'll just go back and forth. So I would say try a problem, check the video, pause it, and just finish off the rest of the worksheet. So on number 3, I want to go from radians to degrees. So if I want to go into degrees, that means I want my answer or my fraction to have degrees in the top, and then I want the radians in the bottom. So the 180 is always the degrees, the pi is always the radians when you're talking about that fraction you're trying to multiply by. So if I multiply across the top, I get 180 pi. If I multiply across the bottom, I get 8 pi. So those pi's cancel out. And then 180 divided by 8 is 22.5. And then we were going into degrees, so I definitely want to make sure I have degrees on my answer. Try 4. So on number 4, we have 3 pi. And we're going from radians into degrees. So if I'm going into degrees, I want the degrees up top, and I want the pi in the bottom so that the radians up top can cancel out with the radians in the bottom. So if I multiply across the top, 3 times 180 is 540. And I'll slide the pi over. If you need to, you can put this 3 pi over 1 to help you visualize it as a fraction. So in the denominators, 1 times pi is pi. And then the pi's cancel out, and we should be left with 540 degrees. Try 5. Again, we're going radians to degrees. So since we want our answer to be in degrees, we want the degrees up top. We want the radians in the bottom. If I just multiply across, 5 times 180 is 900. I'll drag the pi along with me. In the bottom, 3 times pi is 3 pi. The pi's cancel out, and then 900 divided by 3 is 300. And then let's remember to always put the units on our answer, so 300 degrees. Try 6. So I'm going to multiply by 180 degrees over pi radians. 12 times 180 up top is 2,160. Let's drag the pi along with us. In the denominator, 5 times pi is 5 pi. The pi's cancel out. Pi divided by itself cancels out to 1. And then 2,160 divided by 5 is 432 degrees. So all 4 of those, we were going from radians into degrees. So every time we wanted to multiply by 180 over pi, because whatever units we want our answer to be in, those are the units we want in the top of the fraction. In 7 through 10, we're going from degrees into radians. So since we want our answer to be in radians, all of these we should be multiplying by pi over 180. Because we want our answer to be in radians, so we want the degrees up top to cancel out with the degrees in the bottom. So on 7, 210 times pi is 210 pi. 1 times 180 is 180. And then again, in the calculator, you could do 210 divided by 180, and then math, frac, enter, enter. And it should reduce it down to 7 over 6. And then don't forget there was that pi up top. So you need that pi to still be up top. And then let's go ahead and add in the units of radians to remind ourselves that our answer is in radians as opposed to degrees. Try 8. So on 8, I'm going to go from degrees into radians. So I want my degrees up top to cancel out with my degrees in the bottom. And since I want my answer to be in radians, I want the top of the fraction to be the pi, because the pi is in radians. When you multiply across the top, you get 120 pi. Multiply across the bottom, and you get 180. And then 120 divided by 180, we want to reduce that, and it reduces down to 2/3. So don't forget there's that pi up top. So 2 pi over 3, and then let's get our radian measurement on there. So radians, or our units on there. Try 9. On 9, we want to multiply by pi over 180. That way our degrees up top will cancel out with our degrees in the bottom. If it helps you, you could put that 35 over 1. Multiplying across the top, we get 35 pi. Multiplying across the bottom, we get 180. So 35 divided by 180 simplifies down to 7 over 36. And then don't forget there was that pi up top. And then let's add our units of radians. And then number 10, we're starting with 1,000 degrees. We want to convert it into radians. So we want to multiply by pi over 180 degrees. Up top, we have 1,000 pi. In the bottom, we have 180. So 1,000 divided by 180 simplifies down to 50 over 9. And then, like always, there's that pi up top, so don't forget to put the pi back up top. Add on your units of radians, and you're good to go. In the last section, I did a mixture, so you actually had to think about which fraction to multiply by. So try 11, and then check it. Try 12, check it, 13, 14, and that's it. On 11, we want to convert 75 degrees into radians. So I start with degrees. If I want to go into radians, I want to multiply by the fraction that has the radians in the numerator, in the top. Pi is the radians, 180 is always the degrees. So if I multiply across the top, 75 times pi is 75 pi. If I multiply across the bottom, 1 times 180 is 180. And then 75 divided by 180 simplifies down to 5 over 12. And then we want that pi symbol that was up top to stay up top. So 5 pi over 12 radians. Try 12. You're going from 7 pi over 2 radians into degrees. So anytime you're going into degrees, you want your degrees to be in the top of the fraction and your radians, your pi, to be in the bottom of the fraction. So if I multiply across the top, 7 times 180 is 1,260. There was a pi up top, so let's drag that across. In the denominator, 2 times pi is 2 pi. When I reduce, pi divided by pi cancels out to 1. And then 1,260 divided by 2 is 630 degrees. Try 13. So 9 pi over 2 radians, we want to convert into degrees. So anytime we're going into degrees, we want to multiply by the degrees up top and then your pi radians in the bottom. And remember, if you are more comfortable kind of cross-canceling first, you can totally do that. It looks like most of these I've just been multiplying across the top and bottom and then reducing at the end. But if you want to cross-cancel at the beginning, go for it. So if I'm going across the numerators, 9 times 180 is 1,620. And then there was a pi up top, so drag him across. In the denominator, 2 times pi is 2 pi. And then reducing, pi divided by pi cancels out. 1620 divided by 2 is 810. And then let's put our degree symbol on there so we know the unit of measurement we're in. Try 14. 300 degrees, we want to convert that into radians. So we want to multiply by the version of the fraction that has the pi up top, because the pi is in radians, and then the 180 degrees in the bottom, because we want to cancel out the degrees. Let's put that 300 over 1, and we'll multiply across the top, and then we'll multiply across the bottom. So 300 pi up top, 1 times 180 in the bottom, and then 300 divided by 180 reduces down to 5 over 3. And there was a pi up top, so let's keep the pi up top, and then we'll add in the radians. And again, just to recap, radians and degrees are just units of measurement that we use to measure angles. It's very similar to somebody saying that they walked, a certain number of miles versus a certain number of kilometers. It's just different units of measurement.